In this video, I'm going to be talking about the inverting comparator. So before we go any further, I will draw the circuit so that we can easily make references. So the circuit diagram on inverting comparator specifically will look like this. We have a V0 here, positive VCC, the minus VSS. We have a V input, we have a V reference. Okay, that is what the inverting comparator circuit looks like. So this one here is the inverting terminal. This is the inverting terminal. This terminal here is a non-inverting terminal. So this is the inverting terminal. This is a non-inverting terminal of an inverting comparator. So what are the features of the inverting comparator? In an inverting comparator, you have to understand that an inverting comparator, the input voltage is supplied to the inverting terminal. Okay, so input voltage is supplied to the inverting terminal. Input voltage or signal voltage supplied to inverting terminal. Okay, so what happens? So input voltage is supplied to inverting terminal. Two, you have to understand that the reference voltage is supplied to the non-inverting terminal. So reference voltage is supplied to non-inverting terminal. So reference voltage is supplied to a non-inverting terminal. So why is it called an inverting comparator? It's called an inverting comparator because the input voltage is supplied on the inverting terminal. So called inverting comparator. Called inverting because the input voltage is supplied. Input voltage is supplied in inverting terminal. Okay. So now, what are the operations of an inverting comparator? How does it really work? How does it really show the greater signal and the lesser signal? So how are the results calculated in this type of circuit? Results. So first one, if it happens that the input voltage here, if the input voltage is greater than the reference voltage, right? Greater than the reference voltage like that, okay? The output is going to be such that we have minus VSAT. Okay, why is minus VSAT being used? Because the inverting terminal here has a negative sign, right? So this will show you that when this one is greater, it is this signal that will be supplied to the output. So that's why it says output voltage is equal to negative VSAT, or it's coming from the negative terminal. So now the other case, when it's the other way around, when the reference voltage, okay, if the reference voltage happens to be greater than the input voltage, in that case, if that happens, we're going to say that the output voltage is going to be VSAT, okay, plus VSAT. So this means that since the reference voltage is greater than the voltage on the input voltage or in the inverting terminal, it means the voltage on the non-inverting terminal is going to be supplied to the output, and that's why it says the output voltage is going to be what? VSAT and what? VSAT. So that is how the inverting comparator operates and calculates its results. So now that you can calculate the input and the output signal, then how does this look like in a circuit diagram. How will this be expressed? Okay, using graph. How can we express the operations? So let's try to express the operations of what? Of an inverting comparator in a diagram. So this diagram would be representing the input signal, okay, the signal that we are entering into the system. So it starts from zero, then the system, the voltage goes up, then the voltage comes down, and then the voltage goes up, and the voltage comes up, and the voltage goes up again like that. So in X, we have the difference of time here. In this way, we have voltage, okay, positive voltage and minus voltage, so which in this case is going to be positive on top. So we're starting from what? From zero, like that. So here what we have is the sinusoidal signal input. Okay, sinusoidal signal input. So we just say the input signal. And there, what's going to be happening actually in the internal circuit area of the system. So inside the system, what will happen will be this. This is what will happen. So here will be positive VSAT. This is the output, right? And then we have a negative VSAT. So in an inverting comparator, what happens here is this. So when the input voltage, okay, when the input voltage here, this is going to be, this diagram is for the output voltage, this diagram is for the input. So here I will say output signal. So in an inverting comparator, here's what happens. When the input signal goes up, what will actually happen will be that this is zero. What will actually happen is that the signal here will go down in the output. When it's up, this is how the inverting terminal operates. So when the signal, input signal is up, the inverting terminal, the signal will go down. When it's going here, when it's going down, here it will be rising up. And then here when it's down, here it will be what? It will be up, like that. Here when it starts going up, here it will be going down. Here when it's up, here it will actually literally be down. And then when it's going down, it will be going up, like that. When it's down, then it will start coming up, like that. So this is why the inverting comparator is called an inverting comparator. It's because only in the inverting terminal, this is how the operation goes. When the signal there is high, the output will be showing that it's what? It's actually low. Then when the signal that you have input into the system starts going what? Starts going down. Here it will start going what? Here when it starts going up, here it is going down. When it's actually up there, here it will actually be down. Here when it starts going down, here it will start rising. And here when it's actually down, here it will be actually up. When it starts going up, here it will be going down. When it's actually up, here it will be down. So the output signal always does the opposite of the input signal when you're working with an inverting what? With an inverting comparator. So that's the inverting comparator action. That is how it really executes its work and its operations in the internal circuitry system. Then from there, you should understand that this change of the output signal of going from zero, it crosses the neutral point, and it goes to up again, and then it goes to the negative again, goes up. So this action of crossing this zero line here is known as the inverting zero crossing detector. Okay, so inverting zero, inverting zero crossing detector. Inverting zero crossing detector. So with the inverting zero crossing detector, that means it's the change of output signal when input signals cross what? Zero. Okay, so the change of output signal from positive VSAT to negative VSAT crossing the zero, the neutral point here, the zero. This is what you call inverting zero crossing detector. So this is the change of output signal from positive, negative, and vice versa positive to negative, and vice versa. So crossing the zero line. So that is what we call inverting zero crossing detector. So that is what's going to be happening in an inverting comparator.